Hi guys, in this video I'm going to be going over problems very similar to what you're going to see on your quiz. The last part of the quiz, it's just going to be looking at what you're learning this week in chapter 5, elasticity. So this is the part of the quiz that's different from your macro uh, students, from the macro students. So anyway, so we're going to look at some problems that are concerned with understanding elasticity. So this first one is own price elasticity, or we could also call that the price elasticity of demand. So we're looking at demand. Why do we know that? Well, that's because in the problem we read from the data right down here shown below in the table about demand. For personal computers, calculate the price elasticity of demand from point C to point D. Classify the elasticity as either elastic, inelastic, or unit elastic. So let's look at what's happening from point C to point D. Well, when we move from point C to point D, the price is going up from 400 to 450, and the quantity demanded is going down from 4,500 to 400. So from this, we know that we're actually moving up the demand curve to a higher price and a lower quantity demanded, okay? So we just simply want to take these numbers and plug them into our formula for the price elasticity of demand, or we can also say own price elasticity. So we want to take quantity, the percent change quantity is in the numerator, or the numerator, and the percentage change in price is in the denominator. So the way we're going to compute the percentage change in quantity demanded, we're going to take the quantity where we ended up at point D minus the quantity where we started at point C, and then divide by the average. So that's going to be 4,000 minus 4,500, right? So we're going to get a negative 500 divided by the average of 4,500 and 4,000. So that's going to give us 4,250. Then for price, we're going to take P2 minus P1, which is going to be 450 minus 400, which gives us a positive 50 minus the average of the two, which gives us 425. And when we do our math, we see that the percentage changes are, or the absolute value of the percentage changes are the same. Quantity percentage change decreases at exactly the same amount as at the, or is the same amount, I should say, as the positive percentage increase in price. So we have a price elasticity of a -1. The absolute value, of course, of -1 is 1. So we determine from that on this portion of the demand curve right here, when we're going from C to D, the price elasticity of demand is unit elastic, right? So it's unit elastic, okay? If it was over 1, it would be elastic. If it was under 1, it would be inelastic, okay? Okay, moving on, we have, now this is a little bit, this one I might take a little bit of time with. You're not going to have to do the math that I'm showing you again, just so you know, on the quiz for this one, but I want you to really understand why what is true here is true. So the first question here is, why is the demand curve with constant unit. In other words, the price elasticity of demand is 1 anywhere on the curve, the downward sloping demand curve. Why does it have to be concave or shaped like you see right here? Right, and if that's true, like a curve that looks very similar to this one, and I even figured it out exactly on a spreadsheet a few years ago. I'll show you real quick. Where are we? Here. Okay, this is a unit elastic demand. I've actually put in a formula here that you don't need to worry about, but I put in a formula that ensures that the price elasticity of demand is exactly 1 at every point here. So this is mathematically correct. This is a unit elastic demand curve right here. So if it looks anything like this, if it's similar, and I would say that the one I've drawn here is similar. So of all the 4 graphs you're seeing here, this is the one that's closest to having a unit elastic demand curve, closest to having a price elasticity of demand equal to 1 at every point on the curve. So let's just talk about that, and then we'll get to the supply. The supply curve is way simpler. So I actually plugged in some numbers on this demand curve right here, and then this linear demand curve down here. Because the mistake a lot of students make is they assume because the slope is constant here, and it is because it's linear, this curve has a constant slope, but does not have constant price elasticity of demand. It's going to be very, very elastic up here, more closer to unit elastic right here, and very, very inelastic down here. Now, the short answer is when we're up here, because we're at low quantities, the percentage change going from 1 to 2 is a much higher percentage change in quantity than when we're way up here in the price going from 10 to 9. And I actually did the math. So when we're moving from 1 to 2 in quantity, that's going to be 2 minus 1, 1 divided by the average, 1.5, over, and if we're moving from 10 to 9 in price, that's going to be 9 minus 10, because we're going from 10 to 9, so 9 minus 10, P2 minus P1 is going to give us -1. The average, of course, is -9.5, and then when we do our math, we see that the percentage change here in price is it's like 10.5% negative, a decrease in price of about 10% or 10.5%, and then an increase, I should say, an increase in quantity of 66% going from 1 to 2. So the percentage increase in quantity is much higher than the percentage decrease in price. So we get a very, very elastic number here. The absolute value would be 6.33, which is way, way over 1. Very elastic. Now, when we move to the other end of the demand curve down here, we're going to be going from 2 to 1 in price and 9 up to 10 in quantity. So the quantity percent change is going to be just 10 minus 9, which is 1, over the average, 9.5, divided by the percentage change in price, which is going to be 1 minus 2, because we're going from 2 to 1 in price, the -1 over the average, 1.5. So we just get the opposite. We get a 10.5% increase in quantity demanded and a -66% or a 66% decrease in price. So So price is changing, the price, the percentage change in price is way higher than the percentage change in the quantity. So we end up with a very low number. We end up with the absolute value of zero, or a negative 0.1159, which is 0.159, which is way below one. So this is very, very, very inelastic down here, because you get such a large percentage change in a price has very little effect on the quantity demanded in terms of the percentage change. Okay, so that's what the math looks like on a linear demand curve. Very, very elastic, more unit elastic, closer to one, and then right down here it's going to be very, very inelastic. So when we look at a curve that is very close to unit elastic, and I just put some numbers in here, just so we can see what it would look like, assuming this is unit elastic, assuming that we have a price elasticity of one all along here. And this isn't exact. I mean, the one that's exact is the one that I actually did on the spreadsheet over here, but it's close. Okay, I can just, I can only draw it so well. So we're just going to make that assumption. Well, if we start off up here, let's see what I did here. The quantity, I said, okay, right. So we start off moving from here to here, right? This is going to be a big change in the price, 10 to 8, relative to a very small change in quantity. Because if you think about going, when the curve is so downward sloping here, you're going to have a much larger change in price than you are in quantity, in terms of just the raw numbers, okay? But because these numbers are higher, and these are lower, then you're going to end up, when you do the math, you're going to end up with a percentage change of 1. So if we take our quantity and we take 1.25 minus 1, which is going to be 0.25 divided by the average of 1 and 1.25, which is 1.125, and we divide that by by P2 minus P1, which is -2 over their average, we're going to get the exact same percentage change for both, except one is positive and the other one's a negative. Quantity is going up, price is going down, and we end up with a price elasticity of the absolute value of -1, which is 1. Now, when we come over down here on the demand curve, right down here, you can see we're going from 8 to 10 in the quantity, which is in raw numbers is 2. And we're only going from 1.25, or $1.25 down to $1, which seems like a smaller change, but when we compute the percentage change, it's going to be exactly the same. And I won't run through this whole thing again, because it's just the opposite of what I did up here. I just switched it around, and you end up with a price elasticity of demand of the absolute value of -1, which is 1. So that's a mathematical example of why that you need to have a demand curve that's shaped bowed in or concave, shaped like this, in order for you to have a constant, a constant a constant price elasticity of demand of 1. Now, the supply curve is very, very simple, because it's upward sloping. So it's going to be, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. So because both of them are moving up, you're going to have low prices, low low quantities at the same time. You're going to have high prices and high quantities at the same time. And then you're going to have a mid-range prices and mid-range quantities at the same time. So a constant, a supply curve that has a constant elasticity of 1 is going to be linear and look very much like this. And I actually did a graph of one just so you can see it. Right here. Let's see right there. So this is what a supply curve looks like with a constant elasticity of 1, constant unit elasticity of supply, Okay. So that's what you need to know in order to answer the question that you're going to get on the quiz, okay? And there's some good, there's some good stuff about this in your book as well. So make sure you have a clear understanding of what a unit elastic supply curve looks like and what a unit elastic demand curve looks like right here, okay? Next, we're going to look at income elasticity. And the way we compute that is we take the percentage change in quantity divided by the percentage change in income. And one way that I remember these formulas is the quantities always go on top and the money value, whether it's price or income, always goes in the denominator. So we have an average annual income that's going to go up from $45,000 a year to $56,000 a year. And as a result, the quantity of wild salmon consumed, and consumed is, the same thing as demanded in a year by the average person increases from 16 pounds to 20 pounds. What is the income elasticity of wild salmon consumption? And then we want to determine whether wild salmon is a luxury, normal, or inferior good. So the first thing we need to do is use the midpoint, the formula, to figure out what the income elasticity is. So the quantity change, percent change, is going to be where we ended up, Q2 minus Q1, which is 4, divided by the average, which is 18, all divided by income 2 minus income 1, which is 11,000, divided by the average of 45,000 and 56,000, which is 50,500. We do the math and we compute the income elasticity to be 1.02. So that means that it is a luxury good because any income elasticity over 1 is going to be considered a luxury. Let me do this real quick. Okay, it's going to be considered a luxury good. If it was greater than a 0, it would be a normal, and if it was negative or less than a 0, it would be an inferior, right? You don't see this term a lot right here. You're going to be mainly concerned with, is it normal or is it inferior? That's what you're mainly going to be concerned with. This is very close to being normal, right? It's just on the edge. So you could say, well, it's really close to 1, so you could call it a normal good, or you could, be very technical and say, well, it's actually a little bit over 1, so it's a luxury. Either way is fine. The important thing is you know how to compute what it is, okay? So it's either going to be a normal good or a luxury good, okay? And the other way you can think about this is that if the consumption goes up, right? when income goes up, then it's going to be a normal or a luxury good, depending on how far consumption goes up. If as income rises, demand goes down or consumption goes down. That means that people make more money, they decide to buy something else better. Then that's when we say it's an inferior good. Okay? Okay, so there you go. The next one is cross price elasticity. Now remember, once again, when we're reading through this, okay, it's giving us the price of socks, and it's asking us about the demand for a shoe. So that this is the quantity percent change in the demand. So we can assume that's the percent change in quantity demand. So this, whatever we have for shoes in terms of demand is going to go on top, and whatever we have for the price changes, the percentage price change in socks is going to go on the bottom. And the cause and effect here is going to be a price change in one good or service is going to cause a change in quantity demanded in the other. So quantity demanded of one good is a function of the price change in another good. And depending on what the relationship is, we can determine whether the two goods are substitutes or complements of each other. So in this case, we're given partial information. We know what the actual cross price elasticity of shoes is with respect to the price of socks. It's negative 1.2. We know what the percentage change of the price of socks is. It says 6% right here. Actually, you know what? Sorry about that. Let me just grab a little bouncing ball here, just so I'll have it. Okay. Yeah. Well, I thought I had it. Hold on. Sorry about that. Let me try it again. Okay. Okay. Now maybe it'll work. All right. Okay. So this is the formula. The percentage change in quantity demanded of shoes divided by the percentage change in price of socks equals the cross price elasticity of shoes with respect to the price of socks. Okay, so we know what that value actually is. We only know the percentage change of the price of socks, so we'll plug that in right there, and we're solving for the percentage change in quantity demanded of shoes. So we simply multiply both sides by 6%, which is 0.06, to isolate this variable, the percentage change in quantity demanded of shoes. We do the math, and we find out that the percentage change in quantity demanded of shoes is a decrease in negative 0.72%. So the quantity demanded of shoes as a result of the positive, let's make sure. Yeah, the price of socks went up. Okay, this is positive. So the price of socks went up. The quantity demanded of shoes went down. This is a negative because why do we know it's a negative? Because they give us the value up here of negative 1.2 as the value of the cross price elasticity of shoes with respect to the price of socks. So that makes this come out to be negative. So when the price of socks went up, the quantity demanded of shoes went down, which, without knowing any formula or anything, just using common sense, tells you, well, if the price of one item went up, which would lower the quantity demanded of that item, which we know, then you know that the percentage change in quantity demanded of the other item, in this case shoes, if that goes down as a result, if people can afford to buy less socks, so they also end up buying less shoes, that means they're complements, right? They have to be. So shoes and socks are complements because an increase in the price of socks causes a decrease in the quantity demanded for shoes. Also, the cross price elasticity of shoes with respect to price is negative. It's going to be a negative if the denominator moves in the opposite direction from the numerator. So if this expression up here is going up and this expression down here is going down, or the other way around, then the overall expression is going to be negative, which means they're complements. If they're moving in the same direction, if one goes up and the other one goes up, or if price of turkey hot dogs goes up, and so the demand for chicken hot dogs goes up, that means they're substitutes. Because if people say, well, I'm not going to buy turkey hot dogs because they're too expensive now, I'm going to buy more chicken hot dogs because they're just as good. And so if these two expressions, percent change in a quantity demanded, moves in the same direction as the percent change in price, then they're substitutes. Okay, and the one down here, I mean, that's true, but don't really worry too much about that. The one the things you want to really know about it is how to determine whether two goods are either substitutes or complements. Okay. All right. Let's see. Where are we here? I think that's it. Okay. So good luck on your quiz. This video is going to be not there, of course. Let's go where it's going to be not there. It's going to be right here in resources, right there. Okay. I'm going to put it right below quiz 1, part 1. All right, guys. Good luck.